Have you ever wondered why the periodic table looks the way it does? This chart isn't just a colorful poster on a science classroom wall. It's a comprehensive guide to every element known to us, a key to understanding the universe at its most fundamental level. The periodic table organizes elements based on their atomic structure and chemical properties. From hydrogen, the lightest element, to the man-made marvels like Ununoctium, the periodic table provides a snapshot of the building blocks that make up our world and beyond. Its importance to the field of chemistry cannot be overstated. It's a roadmap used by chemists, guiding them in predicting how elements will interact. Each element's position, its neighbors, even its row and column all provide invaluable insights into its nature. Understanding the periodic table is like having the keys to the universe's elemental building blocks. So buckle up as we delve into the fascinating world of elements. The periodic table is not just a random assembly of elements, but a well-organized chart. Think of the periodic table as a city map with its streets and avenues. Like a city, it's divided into sections, or in this case, groups and periods. Let's start with groups, the vertical columns on the periodic table. These are like the avenues of our city. Each group houses elements that share similar chemical properties. Why? Because elements within a group have the same number of electrons in their outermost shell, also known as valence electrons. These electrons are the social butterflies of an atom, ready to interact and form bonds with other atoms. Take group 1, for example, the alkali metals. They have one valence electron, making them highly reactive. Skim down the group and you'll find elements like lithium, sodium, and potassium, all sharing this characteristic. Now let's turn our attention to the periods, the horizontal rows on the periodic table, or the streets of our city. Periods are a bit different. They represent the energy levels of an atom's electron shell. As you move across a period from left to right, each element has one more proton and is less metallic than the previous. This results in a pattern of properties that is repeated with each new period. Take period 2, for instance. It starts with lithium, a soft reactive metal, and ends with neon, a non-reactive noble gas. This shift in properties is not random, but a consequence of the increasing number of protons and the changing distribution of electrons. So, the periodic table isn't a haphazard collection of elements. It's a meticulously designed map using groups and periods as coordinates to navigate the atomic world. It's through this organization that we can predict the behavior of elements and make sense of their properties. Essentially, the periodic table is a map, guiding us through the atomic properties of elements. Group 1 on the periodic table is home to the alkali metals, a fascinating group of elements. These metals are more than just another bunch of elements. They're a family with shared characteristics. For starters, alkali metals love to react. Give them water and they'll fizz, pop, and sometimes even explode. Leave them open to air and they'll tarnish before your eyes, reacting with the oxygen. Now, if you've ever held a piece of alkali metal, you'd be surprised at how soft they are. Unlike their heavy-duty metal cousins, these elements can often be cut with a knife. They're also lightweights in the world of metals. Alkali metals have low densities, with some even being light enough to float on water. So whether it's their fiery reactions, their soft touch, or their light-as-a-feather nature, alkali metals always stand out in a crowd. Alkali metals are a perfect example of how elements in the same group share distinct properties. Now let's shift our focus from groups to periods and explore their significance. Picture the periodic table as a bustling city where each period is a bustling street stretching from one end of the city to the other. Each period, or street, contains a unique blend of elements, each with its own quirks and characteristics. The periods are determined by the atomic number of the elements. This number is essentially the identity card of an element, representing the number of protons in an atom's nucleus. As we move from left to right in a period, the atomic number increases, indicating an additional proton in the nucleus. Starting our journey from the first period, we encounter hydrogen, the lightest and most abundant element in the universe. With just one proton and one electron, hydrogen is the simplest of all elements. It's a bit like the first house on our street, small yet significant. As we stroll down the street, we see the atomic number increase, and with it the complexity and diversity of the elements. We encounter elements like carbon, the backbone of life, and oxygen, the breath of life. We see metals, nonmetals, and metalloids, each with their unique properties. Further down the street, we meet heavier elements like iron, the element that courses through our blood, and gold, the element of luxury and luster. We see the properties of elements change as we move across the period. For instance, elements at the start are reactive metals, while those at the end are noble gases, known for their lack of reactivity. Finally, we reach uranium, the heaviest naturally occurring element on our street. With 92 protons, it's a far cry from the simplicity of hydrogen. Despite its weight, uranium is unstable, always on the brink of radioactive decay. It's the last house on our street, a bit mysterious and somewhat dangerous. So each period of the periodic table takes us on a journey from one side of the chemical spectrum to the other. The periodic table is not just a scientific tool, but also a work of art. In its very essence, the periodic table is a symphony of order and symmetry, a testament to the inherent beauty of the natural world. Its meticulously arranged cells and columns house elements, each with unique characteristics, yet all interconnected in a grand design. Just as a painter uses a palette of colors, the universe uses these elements to create everything from the air we breathe to the distant stars that twinkle in the night sky. The periodic table is a canvas that reflects the beauty of scientific order. The elements are grouped not arbitrarily, but in a way that reveals underlying patterns and relationships. The vertical columns or groups house elements with similar properties, while the horizontal rows or periods represent the progressive filling of electron shells. This careful placement of elements is akin to a finely tuned orchestra, each element playing its part in perfect harmony, contributing to the overall symphony of life. Beyond its scientific significance, the periodic table is also a testament to human curiosity and our relentless quest to understand the world around us. It stands as a monument to the collective efforts of countless scientists and thinkers who, over centuries, have sought to decode the mysteries of the universe. From the discovery of simple elements like hydrogen and oxygen to the synthesis of complex ones like rutherfordium and seaborgium, each addition to the table marks a milestone in human knowledge and ingenuity. In its elegant simplicity, the periodic table bridges the gap between science and art. Its intricate structure and the stories it tells resonate with the beauty of a well-composed piece of music or a carefully crafted sculpture. It's a testament to the fact that science and art are not disparate entities, but rather two sides of the same coin, both striving to make sense of the world and our place in it. The periodic table is indeed a masterpiece, blending science, history, and art in one chart. To wrap up, let's revisit the key points we've discussed. The periodic table, a marvel of scientific discovery, is the Rosetta Stone of chemistry. It's a meticulously organized chart that categorizes the atomic structures that make up everything in our universe. From the hydrogen in our water to the gold in our jewelry, every element finds its place on this table. We've explored the concept of groups and periods, the vertical and horizontal rows that give the table its structure. Groups share similar chemical properties, while periods represent an increase in atomic number, a stepping stone that showcases the evolution of atomic structure. This ingenious layout allows us to predict the behavior of elements and their interactions with each other. We delved into the unique properties of alkali metals, the first group in the table. These elements are incredibly reactive, especially with water, and they're essential for life and technology. From lithium in our batteries to potassium in our bodies, alkali metals are everywhere. Then we journeyed across a single period from hydrogen to uranium. With each step, we saw the diversity of elements, from gases to metals, each with unique properties and applications. Hydrogen, the lightest and most abundant element in the universe, powers the sun and the stars. Uranium, heavy and radioactive, fuels nuclear reactors and atomic bombs. The beauty and wonder of the periodic table are not just in its organization or the elements it contains. It's about the stories it tells and the secrets it holds. It's the story of our universe, from the Big Bang to the formation of stars and planets. It's a secret keeper of the atomic structures that make up everything we see and touch. So the next time you look at the periodic table, remember it's not just a chart, but a wonder of science that holds the secrets of the universe.